In this video, we're going to be looking at the practice problems from the electron configuration page. The first question asks, how many valence electrons does bromine have? I'm going to show you a shorthand rule, but for right now, to find the valence electrons, we're going to draw out the electron configuration for bromine. So bromine has an atomic number 35 and is located in the fourth shell in the p orbital. So to start by writing this out, you're going to write out each shell and orbital that comes before it. So the 1 shell, 2 shell, 3 shell, and then up to the 4p shell and orbital, and then that's how you'll figure out the valence electrons. So to first write it, it fills the full 1s, so you write that with 1s2, since there's 2 electrons in the 1s shell. Next is the 2s, and since there's 2 electrons in there, that's going to be 2s2. Now next, if you're reading left to right, is the 2p shell, since that's across the periodic table, and in the second shell, you're going to write that as 2p6. After that is the 3s shell, and since both electrons are filled in that shell, it's going to be 3s2. And since you're reading left to right, across that is going to be the 3p shell, and since all 6 electrons are filled, that's going to be 3p6. And then finally, the 4th shell, you're going to write that as 4s2 since all the electrons are filled. Now, even though the 3d shell is in the 3rd shell, it still has a bigger shell and a higher energy. So that's going to come after the 4s2 shell. So you're going to write that as 3d10. And then lastly is the 4p shell. And since 5 electrons are filled in that shell, since bromine is in that 5th spot, reading from left to right, you write that as 4p5. So now to look at valence electrons, you're going to look at the highest number shell. So the 4th shell in this instance. And since there's 2 electrons in that shell, 5 electrons in the p shell, then there's going to be 7 valence electrons in total. Now, a shorthand rule of reading this is just looking at the periodic table, but disregarding the transition metals because they don't really have a set valence electron. And you're going to look at the columns for each of these. So the hydrogen column, that's going to be 1. Since all those valence, or all the atoms in that column have a valence electron of 1. And then to the right has 2, since all those atoms in that column have 2 valence electrons. And then looking across, disregarding as well the f orbital, this is going to have 3 valence electrons. All of those have 3 valence electrons. And then this is 4, 5, 6, 7, and then the full valence electron 8, with all the noble gases having 8 valence electrons.